Following on from the earlier video, we got to this stage here. We got to this stage here where I said I would elaborate more on this C. So looking back at Taylor's formula, this C here exists somewhere between A and X. And in the past, I would use Rowe's theorem to explain the concepts behind this C. We don't know where C is. We just know that C exists in between here and in between here. It must exist somewhere in between there. We just don't know precisely where. And I've already explained this in the past. So if you don't understand this, then track back to one of the earlier videos. So looking at this is Taylor's series. So it's being shifted across by A. So looking at this, it's being shifted across by A, but we are not interested in this scenario. You see, we are looking at the Maclaurin series. This is a Maclaurin series where A equals 0, where it's centered at A. This is being, we are looking at A, X minus A. We are not interested in A being, we are not interested in it being shifted across by A. We are interested in the Maclaurin. This is a Maclaurin series, so we are interested in this scenario. So looking at this, you can imagine this as being your Taylor polynomial here, and then when so this purple line here represents your Taylor polynomial. So that represents this, and then when you add your remainder, it will map the Taylor polynomial on top of the function, and then when you add your remainder, this remainder, it will shift it up. It will map this polynomial on top of this function. You can imagine this as being something like this. So when you take away your remainder, it will map the polynomial on top of the function. So when you take away your remainder, it will map this on top of the function. You can imagine this as being something like this. So when you're here, if you take away your remainder, it will map this on top of the function. Or when you're over here, if you add your remainder, it will map this thing on top of the function. So now we need to our aim here is to show that as n heads towards infinity, this remainder here tends to 0. So when the remainder tends to 0, it means that the gap, your remainder here, you can think of it as being the gap. As the remainder tends to 0, it means that the gap is getting smaller and smaller and smaller, meaning the polynomial map on top of the function. So we need to check that it works for all values of x. We need to check that it works for x being greater than 0, x being less than 0, and x being 0. I will continue in the next video.